Suppose I have a universe here. In this universe, I stick a proton. All right, I have a nice proton, that's all well and good. And now I stick a second proton in there. What's going to happen? Well, I assume most of you realize that they're of like charges, they will repel each other. The fundamental question here is, how does one proton know the other proton exists? And so that is the difficult question that physicists had to overcome. And so what do physicists do when they don't have an answer? They make stuff up. Now, the stuff that they make up that turns out not to be true gets lost to the dustbins of history, and the stuff that they make up that actually does turn out to be true, or at least has some credibility, is the stuff that we learn about. And so let's learn about one of those things. So the idea was that if this proton knows the other one exists, it's not like you put the second proton down and it looks with its eye and says, oh, there's a proton. There has to be something there before this proton exists. So this proton must be giving off something, and I'm probably the only one who refers to them as such, but I've sort of referred to them as electric pheromones. That this is giving off this sense out here that the second proton comes in there and doesn't know the proton's here, it just senses this pheromone. So what is it giving off? Sometimes I think of Pepe Le Pew giving off its incredible scent. However, physicists were more sophisticated than that, so they came up with this thing known as the electric field. The symbol for electric field is E with a vector symbol over it because it's a vector quantity. Does the electric field really exist? Physicists actually did not know. When they came up with the idea of the electric field, it was quite a while. It wasn't until the 1870s that they eventually went, oh yeah, the electric field does actually seem to exist. So if the electric field is dependent only on one charge, how do you come up with a formula for it? Well, you go to the force formula for the electric force, which is K Q1 Q2 over R squared. 1 on 2, 2. And they said, well, let's just get rid of one of the charges. So they basically said, well, we can get rid of it or we can divide by it. So since 2 is the center here, let's get rid of 1. And so what we're left with here is KQ2 over R squared, R2 hat. And that is the electric field from charge 2. Or we can write it as just E is equal to KQ over R squared, R hat. Since there's only one charge, do we really need the subscript anymore? So this is the electric field given off by a particular charge. Note that if Q is positive, this whole term here becomes positive. The electric field is in the positive R hat direction, in other words, away. If Q is negative, we end up with a negative quantity here. We end up with negative R hat, which means it's towards it. So we can generalize it, electric field away from positive toward negative. Now, the next scenario is, how do other charges react to an electric field? Suppose I have an electric field going from left to right. There are 3 possibilities. I have a positive charge over on the left-hand side. I have a negative charge on the right-hand side, or I have both. So if I put another charge here, let's say I put a proton here, it has no idea what's causing this electric field. All it knows is the electric field is going to the right. Well, I know that if there's a positive charge here, the proton will be repelled. In other words, the proton's going to go that way. Over here, if I put a proton in this one, it doesn't know that there's a negative charge over here. What it knows is that there's an electric field going to the right, but we know, because of the forces, because opposites attract, the proton will also be attracted to the right. In this third scenario here, I've got a proton here. It doesn't know that these exist. It just knows there's an electric field going to the right. Well, but we know that the proton is going to be repelled by the positive charge and attracted to the negative charge. In all 3 scenarios here, the proton has no idea that these charges exist, but it will still go in the same direction as the electric field. So positive charges move with the electric field, with the external electric field. Now, if I suck an electron here, the electron, again, doesn't know that these outer things exist. It knows, the electron only knows the electric field, but we know that the electron will be attracted to the positive, it'll be repelled by the negative, or it would be attracted to the positive and repelled by the negative. In other words, negative charges move opposite to external electric field. We now have two explanations for why opposites attract, or in some sense, if I have a proton here and I have a proton here, explanation number one is that like repels. Explanation number two is that one proton is giving off these electric field lines. The second proton feels this electric field and moves in the same direction. So we have two explanations for the behavior of these two protons, why they will repel each other. We will ultimately come up with four explanations for the exact same thing, but we're not there yet.